Okay, here's our next video. It's the 2015 number 4. I'm continuing on our theme of differential equations. I'm just going to bring the page on for a moment, and I'll bring it back in a minute. They're giving us a differential equation. We're probably going to solve it, but maybe not. We'll find out. And they've given me a slope field I'm going to fill in, and they gave me some other questions, which we'll answer along the way. Please be aware, part A, B, and C are gettable by most. Part D is usually really hard. We'll take a look at it as we go and see if we can get any of the points out of there. So it says, consider the differential equation, dy dx equals 2x minus y. Part A says, on the axis provided, sketch a slope field for the given differential equation, and the 6 values listed. So there's 1, 2, 3, 4, 5, 6. We have to put into the differential equation, and I've written down all those points with the x's and y's, and we're literally going to figure out what the slopes are of each of those things. So when x is 0, and y is negative 1, we get a slope of 1. At 1, negative 1, so that's 2 minus 1 is 3. And then we've got 0 minus 1 is negative 1. 2 minus 1 is 1. 0 minus 2 is minus 2. And 2 minus 2 is 0. Now, how did I get those numbers? I literally just put them into the derivative equation right there and found those values, and I'm going to sketch them on there. I'm going to do the easiest one first, which is at 1, 2, the slope is 0. So I'm going to sketch a line like so. I'm going to do the slopes of 1 and negative 1 next. At 0, negative 1, the slope, I did this one already. At 0, negative 1, the slope is 1, so I'm going to go 45 degrees. If it's not exact, it's okay. At 1, 1, the slope is also 45 degrees. Got that. At 0, 1, the slope is negative 1. So it's going to be negative 45 degrees, kind of like so. And then I'm going to make things at 1, negative 1. I'm going to make them slopier than that right there because they have a slope of 3, so I'm going to go up like that. And at 0, 2, it's going to be negative 2, so I'm going to go slopier. Doesn't have to be perfect. Down like that. Doing that enough right there is enough for 2 points on that particular problem for the slope field. Okay, the next part says find d squared y over dx squared in terms of x and y. So to find that, I'm just going to take the derivative of this statement right here. So this is all based on x, so I have to use implicit differentiation. So d squared y over dx squared, the derivative of 2x is 2. And the derivative of y is 1 times the derivative of y, which is dy dx. And that answer is correct, but they want it in terms of x and y. So it's going to be 2 minus 2x minus y. Now the question is, where did I get that 2x minus y from? This answer is correct, but dy dx they already gave me. And I have to loop it back in and bring that number on into the problem. So leaving it like that is totally fine for the equation for dy dx. And they asked me about concavity. They say determine the concavity of all solutions in quadrant 2. So all I need is a value from quadrant 2. So I'll pick the point 1, negative 1, quadrant 2. I have to pick a point in quadrant 2. That's not in quadrant 2. So to check concavity in quadrant 2, concavity is always based on the second derivative. I'm going to pick a point in quadrant 2. So I'm going to pick the point negative 3, 5. Because negative 3, 5 would be in that quadrant there. Let's fill those numbers on in. So negative 3, 5 would be, the second derivative would be this statement right here, which would be 2 minus 3 times 2 is negative 6, minus 5, which equals 2 minus 11, which equals 13. Okay, so in quadrant 2, d squared y over dx squared is positive. So concave up. Okay, part 3. Another one we can get. I'm gonna bring it back on the screen so we can read it here. It says let f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. So the question is, are they asking me to solve this differential equation? Let's take a look. Because I already know this differential equation, when it's written in this form, is really tricky to solve unless you have a calculator. Does f have a relative minimum, a relative maximum, or neither at x equals 2? Justify your answer. Well, it didn't ask me about the actual function. It asked me for a relative min, max, or neither. So min and maxes occur at high points, low points, or cusps. And what's true about those is the slope at those, dy dx, is equal to 0, or dy dx is undefined. So if I can find the slope at that 0.23, I'll know whether it's a max or a min. Do I have an equation for slope? Yep, slope is dy over dx. So let's try it at that point, dy over dx. At 2,3, let's fill it in. 2 times 2 minus 3 equals 4 minus 3 equals 1. So it has neither a max or a min. If I had gotten 0, I would test both sides to see whether it was increasing or decreasing, but because I don't have it, I don't have to worry about it. I've got that piece right there. Okay, now the last part of the problem, when I tell you it's really hard, it's got some really hard components to it. Let's take a look so we can see here. It says find the values of that contain m and b, of the constants m and b, for which y equals mx plus b is a solution to the differential equation. So they want us to figure out when this is a solution to the differential equation. Well, remember, if it's a solution, it's going to be touching that line exactly. M is the slope, so m is dy dx. And once we get that piece of the problem right there, we can actually start to figure out the problem as it goes. And even if you can get this part, it would end up being okay. If dy dx equals m, that means that m, let me slide this over, is equal to 2x minus y from the equation up above, up over there. And that would mean that also 2x minus y So we have now it's a whole bunch of things that are equal to each other. We know dy dx is m, so m is equal to 2x minus y. We also know that y equals mx plus b. So that means that this equation right here can be rewritten as m equals 2x minus mx plus b. Ooh, hit my page there. Sorry. If I was to simplify that a little bit, I would get that m equals 2x minus mx minus b. As you read that minus sign. And I'm trying to use that information to solve for m and for b. Okay, so trust me when I tell you this is a hard one to get if you don't. Okay, so what we've done so far, oh, my page is on top. Put it up there. Is we have stated that dy dx equals m, because we know that the slope of this has to match the slope of the curve over there. And that means that m is equal to 2x minus y, because that's what that function is there. If I got that much down, I got 2 points on this problem. So the last part is figuring out what m and b could be to make this function work. So we're going to give it a shot. If you don't get this part, it's okay. It was a really hard problem on the AP. Let's take a look at it together. Okay, so if we got that part right, I said we got 2 points on it. Let's see if we can get the last part. It's really hard, and you got to be very intuitive on the problem. So I know that y equals mx plus b, dy dx equals m, and m equals 2x minus y. I'm trying to solve for m and b, so I'm going to sub in what I know about y. Y is equal to mx plus b. I'm then going to distribute that minus sign x minus b. And what I'm going to do is I'm going to move everything to one side of the equation. I'm going to get, the whole thing. I'm going to get m minus 2x plus mx plus b is equal to 0. So I sort of shifted everything over, and I'm going to do a little fancy work here. So after I moved everything to one side, I took these two terms and I factored out an x. I'm left with negative 2 plus m. And I'm left with plus m plus b. And I wrote this problem out so we can think of it in two separate pieces. We can think of this portion here and this portion here. Now, x could be any number, because x is a variable to go in. It could be a positive, negative, whatever number. The only way for this thing to be 0 is for these two pieces to balance each other out. Right here. And kind of the only way it's going to happen is if both of them are 0, because x could be any number. So any number times 0 plus 0 is going to be 0 in the equation. So that means I'm going to take the first part, and I'm going to set negative 2 plus m equal to 0. That means m is equal to 2. Now that I know m is equal to 2, I know m plus b has to be equal to 0. 2 plus b is equal to 0, so b has to be equal to negative 2. A lot of work for that last little 1 point. Let's not focus in on it. Let's worry about the big picture on the problems, which is they gave us a differential equation. We need to create a slope field. They asked us not to solve, but to take derivatives of it. And they asked about concavity, which is based on the second derivative, and maxes and mins, which is based on the first derivative. Those are the big pieces. We'll do another one in a little bit. Take care.